طيب بسم الله الرحمن الرحيم. So we started in chapter 4 talking about user authentication and key distribution. So today, inshallah, we are going to talk about the first application level standard that that is used for both user authentication and key distribution. So Kerberos is a name of historical Greek character. So the standard that was developed, it's not a standard per se, but it's a de facto standard. So it was not really standardized by NIST or IETF or something, but it's widely used. So we call it a de facto standard. Kerberos has been developed by MIT, and later on it's widely used by many systems. So the motivation for this is that we have a distributed environment where we have many servers. These servers could be geographically located or could be anywhere. So these servers could be actually integrated through the internet, open network, or it could be connected using private network. Users at workstation wish to access services. So these servers, they provide some kind of different services. Some servers, they provide email. Some servers, they provide web service, anything, any kind of service. Blackboard or whatever. Type. Servers then need to restrict access to authorized users. So based on this, they need to facilitate or they need to provide user authentication by which they can grant to a specific user from a specific workstation to be able to use a service from one or more of the servers in that distributed system. So in this environment, a workstation cannot be trusted. So any workstation cannot, even as we would say, even the centralized servers, they cannot be trusted. But the user cannot be trusted to identify its users correctly to the network services because طبعا هنا we will talk about 3 possible scenarios that based on which we cannot trust the user because this user might be illegitimate and he can be attacker. Okay? طيب. So what are the possible threat scenarios that we are considering as part of Kerberos? Okay? We cannot design this system based on being 100% protected because it's not possible. So we have certain assumptions that we have always, when you design a security system, you have to provide like some threat model and possible threat scenarios because you cannot cover everything. So the assumption here is that we are covering 3 possible scenarios. One is that a user may gain access to a particular workstation. So basically, you have like a workstation, and you are a legitimate user. Okay. You have legitimate credentials. Okay. So you can use that workstation to access set of servers. Okay. This server might be an email server. This is web. This is Blackboard. This is whatever. Okay. Services. They provide certain services. So the legitimate access is that this is a legitimate user trying to use his user authentication to gain your laptop, مثلا, or your workstation, to gain access to these services on the servers, right? But a possible attacker might come, Darth, or Eve, or whoever. They can actually get your credentials, okay? And they can log on to this workstation as if he or she is you, and they gain illegitimate access to these workstations, right? So the assumption here is that this user does not know the password because if he or she knows the password, then خلاص, everything is done, right? Another threat scenario is that a user may alter the network address, in fact. So instead of a user trying to gain access, أنت مثلا you logged in and you walked away. someone else might come and gain access to this workstation and trying to get access to these. Because once you log in on this machine, this user on this machine is granted to access these services, right? So if you walk away and somebody else comes in, he can do whatever you are doing, right? He can use the same session and gain illegitimate access to the service, right? Another possible scenario is that Darth بقى, instead of using your workstation, the attacker can use another workstation. Okay? The attacker can use another workstation, and he can manipulate this workstation, assuming he can, to send requests as if it's coming from this workstation and as if he's you. Okay? هتقول لي ازاي؟ They can actually manipulate the workstation to have the same IP address or to have the same MAC address sometimes. There is some attack that you can spoof the MAC address, right? And they can use another workstation to send requests as if it's coming from you on another workstation. Okay? So a user may alter the network address of a workstation so that requests sent from altered workstation appear to come from an impersonated workstation, right? So the requests that are going, it's going to these servers as if it's coming from that user on that machine. That's assuming that this attacker does not have physical access to this workstation. They can use another workstation to do the same. Or a user may eavesdrop on exchange and use the replay attack. So the user can leak some of the communication messages and then replay it again in another time, right? And as we said, replay attacks can be mitigated easily using what? We talked about that before. How can I mitigate replay attacks?
Changing the key.
لا. Changing the key. Changing the key is important to mitigate crypto analysis. Okay, we should bring this as a question in the quiz. But the replay attack is what? Replay attack is that you don't know the key, you don't know anything. You can get the exact message and then later on play it as is. It's encrypted. You don't know what's inside. But you replay it in another time. This is some kind of active attack which can corrupt the entire communication. If I send you 2 copies of the same message in different times, this may corrupt the communication. Okay? Depending طبعا على البروتوكول, depending on the protocol. But I can mitigate the replay attack easily using what? We talked about this before.
Wireshark.
Eh?
Wireshark.
No, Wireshark, yeah. Replay attack, we talked about this before. خلاص, leave it.
Example for the car key.
Yes, this is an example for car key, and we said that we can
just make sure the key has not been used or the message has not already been received.
ازاي بقى عن طريق
Checking you compare the message received to messages.
It is the same, but what tells me that this is a fresh message versus this message is actually an old message?
Update the message. The time.
أيوة. إيه?
The time.
The time or sequence number. Okay. So I have to always renew the timestamp or the sequence number to give an indication that this is a fresh message. Okay. So if you play the same message, then as you said, I will check. I received this message before in the system, so I will reject it. So I have to have a mechanism like this in order to say that this is a fresh message or this is an old message. So this way I can mitigate the replay attack easily. And this is what this standard actually uses. The standard uses some kind of timestamp. Every time you send a message, you have to update the timestamp. It's very important. Type. This is the threat scenarios that this standard tries to cover. In this threat model or these threat scenarios, we are trying to achieve user authentication key distribution to facilitate the access to some distributed services. Okay, so this is what this standard. طيب, based on that بقى, the key distribution and user authentication service developed at MIT. As we said, later on it has become a de facto standard widely available in many distributed systems. But just the fact that it's a distributed system doesn't mean that key distribution and everything is done in a distributed way, because we cannot trust everyone. It has to be done through a centralized service. So actually, user authentication and key distribution is one of the services, okay, that you have to first try before you gain access to any other service. So it provides centralized authentication server. So there is a centralized authentication server, which we called it a key distribution center. لو أنت فاكر. We talked about this last time. So we have the concept of key distribution center. Here we call it authentication server. Same terminology. ماشي? Whose function is to authenticate users. Authenticate users معناها this server knows your user ID and password. إزاي? There is a claimant or a subscriber or a user who tries to identify themselves, registration, we have talked about this last time, right? And then this standard relies exclusively on symmetric encryption. So there is no public encryption calls. In the second part of the chapter, we talk about another standard which is using by certificates, using public cryptography. But here, it's purely based on symmetric cryptography. No public cryptography calls, no public key and private key. We have only symmetric key. And this is a challenge, as we will see, because in public encryption, public cryptography, key distribution is easier. It's easier. But here, key distribution is very much attached to the user authentication. Very much attached to user authentication. ماشي? There are two versions, version 4 and version 5. The only difference is version 4 has become a little bit outdated. It still exists, but it's a little. The only difference is that in version 4 they used to use this. In version 5 they realized that this is complex, and at the same time the key size is small. حد فاكر كان كام؟ لا الدس الكي size. لا مش 64. 56. Okay? 56 bits. Okay? البلوك سايز هو ال 64. الكي سايز 56. ماشي؟ فكي size is small, right? And it's complex. So we need to increase the key, but this does not standardize any other key other than 56. So in version 6 they started to use the AES, because AES provides 128, 256, مش عارف 192. They provide other key sizes, and it's much less complex, right? So you can increase the key size easily, right? This is the only difference between version 4 and version 5, really. Type, in terms of terminology, these are very, very important terminology that Kerberos uses. So it's a third party. So you will see here the terminology is different from what we have talked about in the NEST standard. We talked about NEST standard اللي هي 600 dash مش عارف ايه. We talked about claimant to verifier. We talked about this, right? Here the naming convention is different. It's slightly different, but you can have one-to-one relationship. So here we have, instead of the key distribution center, here we talk about authentication server. They call it AS. ماشي? So the user initially negotiate with the AS to identify themselves. Right? So you have already registered, and then you want to verify yourself. When you verify yourself through user ID and password, you should get what we call provide non-corruptible authentication credential in a form of a token. فاكرين احنا قلنا when you verify yourself, the verifier will give you back some kind of a token. Here they call it a ticket. ماشي? So imagine yourself going into the cinema, for example. So first, you say, okay, so I want to watch a movie. Then you say, you pay. Once you pay, you get a ticket. This ticket grants you access to the cinema, okay, for a certain period of time, for a session, right? But here, this session is long-term, because authentication server will give you access, in fact, to all the services, not to a specific service. It gives you access to the distributed system as a whole, right? But it's not enough for you to access a particular service. ماشي? So this is called ticket granting ticket. It's not enough for you to access a specific service, but it's one step towards gaining access to a particular service. Then, using this TGT, you have to request the ticket granting server. Okay? It's like you're getting to the cinema, you have a ticket. This ticket admits you to the cinema, but not to a particular movie. Something like that, right? Then you go, and then you say, I want to watch that particular movie. They say, oh, okay, so what is your ticket? Okay, so this ticket is valid. I'll take this ticket, and I will give you another ticket, okay, which is valid only for this movie, right? So this is called ticket granting server. The ticket granting server, you have to request from the ticket granting server, right, that you want to have access to a particular service, okay, for a duration of time. Then this ticket granting server will give you back another ticket, right, which is valid only to access a particular service from a particular server from a specific workstation that you work on. Okay? So this ticket is actually, it binds your access credentials and your workstation that you work from, okay, to a particular server that provides a specific service for a duration of time. ماشي كده؟ Okay, so the only difference is that, as we said, in version 4 they used to use DES, and now they use AES in version 4. Not that they have discovered any flaw or any pitfall in version 4, يعني, but they were trying to make themselves more future-proof, okay, in terms of increasing the key size. So they said, okay, let's support AES instead of DES. ماشي كده؟ طيب. So, what are بقى the requirements for Kerberos? What are the requirements? يعني, what are the benefits of Kerberos? So they talked about a particular يعني, 3 or 4 different scenarios that we want to achieve as part of this standard. Number 1 is that if a user C logs on a workstation in the morning and wishes to check his or her email at server V, okay, then they need to provide their credentials, right? They need to provide user ID and password. But C authenticates through AS الأول اللي هو authentication server to get a ticket. But C must use the password to get the ticket. So how can we send the password in plain text? How can we negotiate, okay, with the server our credentials using the password? Because remember, we are doing this step in order to get the key. We didn't get the key yet. But in order to get the key, we have to provide user authentication. You have to send the password. Right? How can we send the password if we don't have a key? We cannot encrypt the password, right? And the password is sent over an open network. So that's a problem now. So the standard needs to solve that issue. So this is one. Number 2, if user بقى C wishes to check the mail server or the mail several times, okay, مش هتفضل بقى every time you ask me for user and password. خلاص بقى يعني احنا مش. So every time I check one email, you ask what's the user. لا, we need to have a way through which that the system, this is the function of the ticket بقى, that the system, when I authenticate the first time, it gives me a ticket to be able to access a particular server for a duration of time, so that I don't have to every time enter the user ID and password. This means that this ticket is reusable. I can use the same ticket, okay, to send many requests to that service server, okay. So the workstation can then store the ticket which means that you can access that ticket and store it locally. But then if that ticket, again, I store it locally, if I can see it, I can replicate it, right? Even the legitimate user can store it, can replicate it, and can gain access مثلا to a different server, which means that this ticket needs to provide access for a time period, but it's non-forgeable. You cannot replicate that ticket. ماشي? You cannot replicate that ticket. Even you cannot replicate. You can store it, but you cannot replicate it. ماشي? This is possible if we have a key. We can sort of encrypt that ticket using a key that even you don't know. And the ticket for you is like you can replay it. So now you can replay the ticket in a legitimate scenario, as we will see. طيب. Still, the user would need a new ticket for every service. يعني if now I'm getting a ticket to check the email. If I want to check Blackboard now, you need to get another ticket, right? You want to watch another movie. مش هتضحك عليا بقى تقول لي لا أنا will use the same ticket to watch another movie. لا. You have to get another ticket, right? You have to send another request, pay تاني, and so on, and get another ticket. طيب, hence, the ticket granting server is needed so user can get a ticket for each service they use. ماشي? So these are the issues or the requirements that this standard may. So what is the architecture? So this is the overall architecture for Kerberos. Okay? So first, in step 1, the user logs on to the workstation and requests service on this host. So when you log in locally, so you can present your password locally, right? The problem is that we cannot send the password as a plain text over the network. Okay? طيب. So instead, once the user logs on, what you will do is that you will send a request, as we will see, only with the ID, not the password. So you will send a request to the AS. And in many scenarios, by the way, in most of the architecture, the authentication server and the ticket granting server is part of the same. يعني they both run on the same workstation very commonly. ماشي? But the architecture itself facilitates the separation between authentication server and ticket granting server. Okay? But you can combine them in one. مفيش مشكلة. So the first thing now, to get around the requirement that we cannot send the password in plain text, we will send only the ID. Okay? But the ID is not enough. I need to verify your password. Okay? Type. So the authentication server will send you back a ticket. Okay? You did not present your password yet. Your password is not sent to the server yet, right? But the server can associate your ID with a particular password, okay, that the server knows. But the server, by the way, does not know the actual password. Even, by the way, your password is not stored on the server as is. Your password is stored in a hashed manner. It's hashed. Okay? Even the server does not know the actual password. ماشي? The server knows some hashed version of your password. And as we know, hashing is one way. You can never go back, right? Yes. So لا هو ما هنشوف دلوقتي. Okay? So first, I send only the ID. Okay? طيب. Number 2, AS verifies the user access rights in the database بمعنى this user ID exists or not. Okay? Then results, what I will do is that I know your hashed password, right? I don't know your actual password. And you did not present me the password, right? So what I will do is that I will try to derive a key based on your hashed version of the password. Okay? And I will use that key to send you back a puzzle or a challenge using the hashed version of your password as a key. Okay? So instead of you sending me your password, whether hashed or plain text, you will not send me that. But in order to make sure that you know the password, that you are really the person who say you are, this is the main purpose of authentication, I will use your hashed password to derive or to develop a key, okay? And then I will use that key to encrypt a message to you, okay? Only if you know that key, you can open that message and know what's inside, okay? What's inside that is the ticket and the session key that we talked about. So that's why here the workstation prompts the user for the password. And that's why, على فكرة, in many cases you will see in systems nowadays, first they give you the email. And then you have to press next, صح? You have to press next. Goes to the server, okay? And then it comes back with the challenge. And now you enter the password. If it matches, we can open the message and know what's inside. Okay? And they use that, by the way, to facilitate the denial of service. Okay? Because I can send many requests with many user IDs and passwords. لا. الأول first, I need to give you the challenge. If you solve it, then you can. So it's a two-step process. Okay? It's not like one step, I send you the user ID and password right away. So workstation prompts user for password to decrypt the incoming message. If you have the right password, you know the key that I have used to encrypt that message. So you can open the message and know what's inside. What's inside is the ticket, which grants you access to the system, not to a service. Okay? And a session key. This session key is long term. Okay? It's a session key, but it's long term. They call it semi-permanent key. Because you can think of it as the master key. ماشي? It's long term because it's not attached to a particular service. ماشي? طيب. If it matches, we can open the message. In the message, now you will see the session, you will know the session key. So now, both you and the authentication server and the ticket granting server knows that session key. Because this session key is sent to that user, and at the same time, this ticket granting server knows that key. Because this key you can now use to communicate with the ticket granting server in order to get access to a particular service. So in phase two, assuming that you are able to open the message and know what's inside, you got the key, okay, and you got the ticket. Then hereby you can send to the ticket granting server a request which contains the ticket, okay, and everything is encrypted using the shared key that you have achieved from the first stage. ماشي? So then you send that request to the ticket granting server and request, I want to have access to a server V, email server or anything. Then the ticket granting server will send you another ticket which allows you to access only server V for a duration of time. ماشي كده؟ And of course, by doing this, it gives you another session key. This session key is temporary key. This session key which you will use to communicate with the server V only. Okay? So you have the main session key, which we can call it master key. This is long term. Using that key you can get many temporary session keys for each service. So for each service, you will get a key and you will get a ticket. ماشي? You'll get a key and you'll get a ticket. And again, the key is used for encryption, the ticket is used for what? For avoiding the fact that every time you have to do the user authentication again and again and again. Okay? The ticket is something that you can store locally. You cannot forge it, you cannot replicate it, but it allows you to access this server several times without having to present or without having to do the user authentication again and again. ماشي؟ واضحة دي؟ So these are the three phases. We'll go through that in details. Okay? Because there is a big application level protocol. So starting from here, we'll get very deep into networks, network protocols بقى. ماشي؟ But here we will think about the network protocol from a security perspective. We are sending messages back and forth. Each message needs to have certain components, okay? But we need to always ask ourselves, why do we need to have this? Why do we need to have this? And why in the protocol we have this? Why we need to send this information? ماشي؟ طيب. So the first phase that احنا قلنا اتكلمنا على 3 phases دلوقتي. 1, 2, 3. Okay? So this is the chronological time order for sending these messages back and forth. حد يفكرني أول ما نوصل ها؟ تمام كده؟ طيب. So the first message I like to always have a format, a unified format for the message. You always have to send this is the server that you want to access next, and this is your authenticator. Okay? So using this authenticator, I want to be able to access this server in the next request. Okay? Just put this format كده in your head, we will need it يعني. So here, I like to make it يعني هو the same, but I like to replace those كده. I like to start with ID TGS اللي هو ticket granting server. So the first request you send to who? To which server?
AS.
To AS. ماشي? You are sending a request to AS to request access to TGS. Okay? ماشي؟ فمعناها ان انت you are requesting a ticket in order to be able to access TGS using that ticket later on. Okay? That's why I said that always put the server that you want to access next first. And then IDC is your username only. This is C for client. ماشي؟ and ID معناها ايه؟ your username. ماشي؟ So ID and timestamp 1. timestamp وليه بقى timestamp 1؟ عشان replay attack. Okay? Okay? واضح كده؟ يبقى احنا عارفين ايه؟ Each one is sent for a reason. We call بقى ال IDC and timestamp 1, we call it Authenticator C. We will call it now Authenticator. يبقى I want to authenticate myself, okay, using ال IDC and timestamp 1. Timestamp 1 is, as we said, for replay attack. ايه؟ لا ID is not hashed, it's plain text. It's your email ولا username مش مشكلة. لا timestamp عادي. ممكن بقى timestamp هو the standard defines timestamp. ممكن instead of timestamp you use مثلا sequence number مثلا in any format يعني. It doesn't have to be يعني timestamp اللي هو big huge timestamp. لا. It's some identifier for that message. But every time you read the message, you have to use a different number. That makes sure this is a fresh message. ماشي؟ حلو كده.
The client authentication, you said it won't be repeated once it's done the first time, depending on the...
ما احنا هنشوف دلوقتي. ماشي؟ طيب. So now the authentication server will send you back. شوف بقى, this is very interesting. Will send you back a message which is hashed using KC. KC is a hashed password mapped into a key. This is done by the operating system. So the operating system locally, okay, can generate a key based on the hash value of the password. Okay? So this is generated on both sides. Okay? Based على ايه? Based على associating the ID on both sides with a specific hashed password. Okay? Using this KC, I will encrypt everything else. I will encrypt the session key, which you will need to access the ticket granting server. This is what you want, صح? ماشي. And in addition to this, I will send you those two fields, which we don't know why we have to do this. This is the ID for the TGS server. Why? Why? Why do we need to send the ID for the TGS server back? And we send you back TS2 again for mitigating replay attack on the other side. Okay? So that no one will be able to replay on behalf of the server. ماشي كده؟ طيب, and a ticket, صح كده? A ticket which you requested, صح? And a lifetime where this ticket is valid. Okay? Which means that starting from this point on, you are allowed to access the ticket granting server over and over and over again. And every time the ticket granting server will say TS2 plus a lifetime compared to current time. Did we pass? If the answer is no, we didn't pass the TS2 plus a lifetime, خلاص, I will grant you service. If we use it for a duration of time and then we go past that lifetime, then خلاص, I will stop. And then I tell you, لا, you have to enter your user ID and password again, and you have to do the same process again. ماشي كده؟ طيب. Until now, we see the ticket, but we don't know. I mean, the ticket for us, it looks like it's plain. يعني, so how can I store it locally and not be able to forge it or replicate it or something like this? We'll see. طيب. So now, if we have the right password, we will be able to open that message, which means that we will have the session key to communicate with the TGS, which is KCTGS. That's good. And then we will have the ticket, which we needed, of course, in order to several times access the server without having to present our authentication again. And we have the lifetime. We know exactly for how long of a period we can use that. ماشي؟ طيب, خلاص, we use this. We use بقى KCTGS from now to send a message فيها ثلاث حاجات. We use this to send the server ID, and we use the ticket TGS, which we can present to the TGS server, okay, in order to tell that TGS server that we have access to your server without having to present our user authentication again. And we have the client authenticator. The client authenticator, as we will see, it contains دايما ال IDC at least, and some kind of timestamp. And the timestamp has to be different every time. ماشي? So we have and here we have the target server that we want to access next. صح? We need that, right? So you are accessing the TGS to request access to another service server, email بقى ولا أي حاجة. صح? So we have to present the ID. These IDs, by the way, are identifiers for a user or for a workstation. ماشي? Could be an address, physical address, IP address, things like that. ماشي? And the ticket, which we got from this stage, assuming we know the right password, and the authenticator. ماشي كده؟ Then, طبعا the TGS will use that session key to encrypt the message back to us, coming back to us. This message, assuming that we know the key, of course, we will be able to open to get another session key, and this one is the temporary key, which can use to communicate with the service server بقى. ماشي كده؟ And the ID of that service server so that we can use it next to send it to that server. and TS4 and the ticket. ماشي كده. I think there should be a lifetime similar to this. Although the lifetime, we'll see that the lifetime is stored inside the ticket. But I'm not sure why we added it here but not here. But there has to be a lifetime for that ticket طبعا. That ticket is valid for a certain duration of time. Once we know this, then we use here you will find that you don't have a target server خلاص. صح؟ You don't want to access anything beyond that service server. خلاص ما أنت you are doing these two steps in order to gain access to the server. Now you gain access to the server. خلاص. So your request here will contain only the ticket and the authenticator. The ticket and the authenticator. You don't want to access anything beyond that service server. That's why I told you that this target server is optional. It has to be there in the first two phases, but in the third phase, خلاص, you're done. ماشي كده؟ But here we see that we are sending a message TS5 plus 1. What is this? TS5 plus what is this plus 1? It's a bit weird. ماشي? We'll talk about it.
This is mostly for the server side security, but not for the client.
Right. So it's actually, yes, this is a good point. So every time you send a message, you have to authenticate yourself. This is part of the message authentication. So the ticket is representing your message authentication to the server, صح? But the server has to authenticate himself back to you, so that I know that the reply is coming from the right server, right? So the way we do this is so similar to Authenticator C, there is Authenticator AS. So this is called mutual authentication. So each side has to authenticate themselves to each other. And of course, these two are part of an encrypted message with KC, right? So you know that I'm the one who knows KC. صح? Once you decrypt the message, and inside the message you see ID TGS, and you see timestamp 2, تعرف إن ده جاي مني, not from anyone else, because no one else will know KC. No one else will be able to give you the right encrypted message. ماشي كده? So this is called mutual authentication. And this mutual authentication is done using a very interesting thing. Is using IDA TGS, which is the next server, صح? صح? So ID TGS is here, right? Which is the target server that you have requested, right? Here you are requesting ID V N, and I have to provide. So you are requesting yes, IDV here and IDV here, right? So it's like an acknowledgement that this is coming from me, okay? So IDV here and IDV here. Here, the interesting thing is that there is no target server. Here in the service server, there is nothing beyond it, صح? So you are already accessing that service server. So how can that service server authenticate itself back to you, which is part of the mutual authentication? Okay? So the only thing in the message that I can echo back is TS5, which is part of the request, as we will see. It is part of the request. So I can echo back TS5 and I make +1. Yes, هنشوفها في الايه اهي يعني هنا اهي as part of Authenticator C, which is this, I'm sending you a TS5, right? So in all of these messages, you will see TS1. In the reply, there is TS2. TS3, you'll find TS4. Okay? So I don't have to use the same timestamp. Why? Because I have a target server, اللي هو IDS, IDTGS, or IDV, to authenticate myself back to you. In the third one, you don't have a target server you are requesting.
So why +1?
IO plus 1 is because it has to be different, but it's related.
So it's like TS5.
ما it has you have to make sure that it's fresh, صح?
Yes.
So you cannot use the same TS5. But you have to
TS5 plus 1.
yes ما هو
And-
عشان yes, so it has to be plus 1. Or it has to be plus something that's agreed upon, so that because it has two purposes here. It has two purposes. It mitigates the replay attack, right? And at the same time, it's used for mutual authentication, right? So that's why I have to echo back TS5, and I have to put plus 1 because I have to verify. You have to verify that this is a fresh message.
And Doctor, I'm telling it, I sent the request at this time, and then it's telling me I received this request at this time.
Yes.
If I see that they took too long to receive it, would there be a protocol to cancel it and start again?
If you only if it times out بقى, only if it times out, which is not. خد بالك احنا هنا بنتكلم على application level protocol. If it times out مثلا from TCP ولا IP ولا, that's another story. ماشي? There is a timeout طبعا in these protocols, but here احنا we're talking about some way to do mutual authentication. So this mutual authentication here is done here and it's done here implicitly, right? It's done here by echoing back the ID of the target server. Okay, so and it's encrypted, so you know. So that's why here we can use a different timestamp altogether, and there is no correlation between TS1 and TS2. It doesn't have to be plus 1 or plus 2 or plus 5. It doesn't have to, right? But here, because we don't have a target server, so we cannot echo back anything other than TS5. So we use TS5 for both, for mitigating replay attack and for mutual authentication. Anyway, type. There's something here, something that we did not talk about, which is what is the content of the ticket. As a requirement for the ticket, it has to be non-forgeable. Non-forgeable, right? So, in order for the ticket to be non-forgeable, the client can store it locally, and this ticket is actually an encrypted message, because we said that the ticket is required to do what? Is required to give you access for a period of time for that particular user on that particular workstation. صح? For a duration of time, right? So that's what's exactly inside that ticket. Inside that ticket, you will see IDC, which is the user name. ADC, we did not see that before. What is ADC? Can anybody guess?
Authentication.
لا. This is the IP or address of the workstation. ماشي? Because we said that you are granted access, okay, as this user from that particular workstation, which means that if you try to use the same service from another workstation, you have to be presented to enter your user ID and password again, صح? This is what typically happens, right?
So it's from the IP?
Yes, so it's based on IP. So the question now, I did not send you this IP. How did you know it? This is يعني بصراحة, this is a bonus question. How did you know the IP?
DNS?
DNS?
Yeah.
DNS is based on domain name. So I have to give you a domain name to map it to.
I think from the IP header.
برافو عليك. شايف الناس؟ الله ينور عليك. صحيح. احنا هنا remember احنا هنا application level. But this application level messages, these are sent using a TCP header or IP header or network access header. Okay? So فعليا what you are sending is the application level message with a bunch of other headers. Right? So when it goes to the AES, authentication server, AES knows that this is coming from that particular IP address. And I can use that ID, the IP address, the physical address, and the port if I want. ماشي? Because everything exists in the header. برافو عليك. ماشي كده؟ So this ticket contains these messages. And the lifetime is here. That's why it doesn't have to be part of the message because it's already part of the ticket. So who can يعني open that ticket and know what's inside? Not the client, صح? The one who has this particular key. خد بالك, this is not the session key. This is the key which is stored at the authentication server and the ticket granting server. Okay? Because this is used as part of authenticating the ticket granting server to the authentication server. Similar to your IDC. Right? IDC is mapped to KC, right? Based على the hashing of the password, right? برضو IDTGS can be mapped to KTGS. Okay? The authentication server knows it, the TGS knows it, but the client doesn't know it. Okay? واضح كده؟ So when I present this ticket to the TGS, TGS will be able to open it. Why? Because it has, of course, KTGS. It has it. So it can open it. So this way it can verify the lifetime of that ticket and the content of that ticket. It can verify by your IP address, your user ID, everything, and the lifetime. And so you don't have to present your user ID and password every time. Okay? And you can store it locally without knowing what's inside. ماشي كده? So this is the same بقى content all over. The same content of the ticket all over. The same thing. Every ticket grants access to a particular user from a particular workstation to access a particular target server for a duration of time.
Changing your IP doesn't break anything, right?
Changing it?
Your IP using a VPN or something, would it break anything?
It will.
Would it break the
Of course. A VPN, you get another IP address, you have to do the whole thing again.
Change the public IP.
Change everything. Because the ticket will be irrelevant in that case. Ticket will not be valid. Certificates, you have to present your certificates again. ماشي؟ ايه؟ خلاص تمام احنا خلاص كده تمام.